Okay, so now we want to know what kind of oil we have that we're going to process into our fuel today. So remember I said that you need a 91% isopropyl alcohol. So you can pick this up in any pharmacy store. You don't have to order it from a chemical company or whatnot. But it has to be 91% isopropyl alcohol. You'll also need a 0.1% sodium hydroxide solution that you will make from your lye that you purchase from a chemical company to make your diesel process. You will need your phenolphthalein, your indicator. You can purchase this from any chemical store. And of course, you need a sample of the waste vegetable oil that you're trying to turn into your fuel in this particular batch. Okay, so let's begin. The process is 10 mils of a 91% or greater isopropyl alcohol. So we're going to get 10 mils of our isopropyl alcohol. Put it into a container. To 1 mil of our waste vegetable oil, which we have in a syringe. So we put 1 mil of our waste vegetable oil into our container. And just a couple of drops of our indicator to let us know when we've reached our acid number. And just kind of shake that around. Mix them up. And then we're going to use a syringe so that we can drop off 1 mil at a time of our 0.1% sodium hydroxide solution, because we use sodium hydroxide. And that's going to give us an indicator of what kind of acid number we have in our waste vegetable oil and how much sodium hydroxide I'm going to actually have to put in here to do this conversion, to break those chemical bonds. So we're going to put it in basically 1 mil at a time, swirl it around. You see that didn't change colors. We're going to put another mil in here. Kind of swirl it around. You can see that it didn't change colors. Add another mil. Swirl it around. Starting to try to change colors, but it's not there yet. Okay, you can see that it changed colors, but you want to make sure you mix it long enough so that the color is truly pink. You can see that this color is getting lighter and lighter the more I swirl it around. So if you stop at this point and you say, well, that was 4 mils of my 0.1% sodium solution, so I think that's all it's going to take for me to put that into my calculation, and then I can have a good conversion. But you can see that it's very, very light pink. I'm not after a light pink color. I want a really dark, bright pink. So I'm going to put 1 more mil of my solution in there and swirl it around again. You can see that it's very dark pink now. We're going to keep swirling to make sure our color stays the same. A lot of people make this mistake in that they don't let the reaction take enough time, and then you won't use enough of your lye or your catalyst in your process, and you wind up making a bad batch of fuel that you have to reprocess, and it costs you more money. So we've swirled. I believe we're pretty safe to say that it took 5 mils of our 0.1% sodium hydroxide solution to turn 1 mil of our waste vegetable oil to tell us what acid number we have. Okay, so we're going to plug these numbers now into a calculation, okay? The calculation that we talked about earlier. So if it took us 5 mils of our 0.1% sodium hydroxide solution to turn our 1 mil of waste vegetable oil and give us our acid number, we said earlier we like to use this 5 as a base number for sodium hydroxide. You'll see it on the internet. It'll be 3.5. It can be 5 or it can be 5.5. We found through our process, through our oil that we collect, that using 5 as a base number for us works well. So that's the number that we're going to use. So it took me 5 mils of my solution to turn that 1 mil of oil, or give me that acid number. So I'm going to multiply, I'm going to add these two together. So that's going to give 10 grams of lye to turn 1 liter of this waste vegetable oil into a fuel product that I can use. Now remember we said we don't really deal with liters, we deal with gallons. Everything that you buy for biodiesel processes is going to be in gallons. So we simply need to do the conversion ratio to turn liters into gallons, and that's going to be okay, so now we've turned our liters into gallons, 37.85 gallons. Now what we want to do is say we're going to use how much lye is it going to take to turn how many gallons of waste vegetable oil we're using. Well, in our processor we use 30 gallons. So we have a 30-gallon processor. Okay, we don't process a whole lot at one time. 30 gallons is all we process at a time. So I want to know now, how much of this lye is it going to take to turn this 30 gallons of my waste vegetable oil into a fuel product that I can use? And if you do this calculation, it's going to take and you divide this by your conversion factor, because I got to get this into pounds. Okay, I'm not interested in grams, I want pounds. And this would equal to 2.5. So, to turn my 30 gallons of waste vegetable oil that I collect from my restaurant into a fuel product that I can use in my trucks and tractors on the farm, I'm going to have to use 2.5 pounds of sodium hydroxide in my process. Okay? So it's simple math, just conversion factors. The most important thing is that you get this base number for your catalyst correct, and you'll only be able to do that through processing and processing and processing. It's going to change as your oil sources change, so it's very important that you do a titration for every oil source that you have, and you continue to do the titration. Do not make the assumption that, well, I've been getting it from this restaurant for a year, and certainly they haven't changed anything in their process. Well, times change, economics change, and they may decide that they need to fry that oil a little longer because it's more cost effective for them to do that. So your titration point is going to change if they start using their oil longer and longer and longer. So never make the assumption that just because I've been getting it from this restaurant for the past year that it's always going to be this titration. You must titrate every batch of oil that you run through your processor. You must do a titration on just to make sure that you're not overusing your chemicals or underusing your chemicals, and that in the end you get these fatty acid methyl esters that you want as a product for your biodiesel.